Thank you, Chris. Welcome, everybody. Um, I want to thank everybody for being here on a Friday afternoon, at least Friday afternoon here in the Eastern US. Just before the workshop, I counted 11 different countries uh, represented by the registrants. So those of you not in the US, welcome to you as well. My name is Joe Hefner, and I'm a slightly retired, 2.5 years, physics instructor, but I'm also playing the role of a LaTeX evangelist today. And what I want to do in this workshop is show you the workflow that I used for the better part of 10 years in teaching my introductory physics classes. Uh, and this was in a 2-semester calculus-based physics course, but I dare say that it could be used in any physics course. And I'm going to show you how I implemented LaTeX in my courses. Uh, I'm not going to stand up here and say that this is the only way to do it. I'm not going to stand up here and say that this is the best way to do it. I'm simply going to say that this is how I did it. And I can tell you with 90 some percent confidence that students found it very straightforward. Don't believe everything you hear about the learning curve for LaTeX. I think that's overblown. Uh, and I think uh, you'll find that students take to this very, very quickly. So the goal of the workshop is for you to walk away with having written up the solution to a physics problem. And one of the things I asked attendees to do is bring a textbook with you, and I happen to have my copy of Matter and Interactions here handy. Any physics textbook will do, and if you don't have a textbook handy, make up a problem. Just a simple physics problem. And I see Tony has his there. Is that Knight? Did I? Okay. So any physics textbook will do from Hewitt on up, because I'm going to ask you to select a problem later in the workshop to write up the solution. And I'm going to show you the tools that I used, including some custom LaTeX software that I designed for writing up physics problem solutions. So that's kind of where we're going with this. I don't know what your backgrounds with LaTeX are. So if you feel that it is necessary, we can do just a very quick refresher/intro to LaTeX. I'm very flexible, but I do want to reserve the better part of the second hour to let you work on writing up your sample solution and perhaps even presenting it like an oral, I'm not going to say an oral exam, but perhaps an oral assessment of some sort. Okay. So let me just show you two other resources that I have handy here with me. The official canonical documentation for LaTeX is this book by Leslie Lamport. And this goes back to the mid-1980s when it was first published. This edition was published in 1994. It's paperback. You can get it on Amazon. I honestly don't know how much it is. I bought this one many, many years ago. But I can tell you that LaTeX has evolved. It is actively under development. And are you aware that LaTeX is released twice a year? Once in June and once in November. And I had no idea all these years that it was under such active development, but it is. And there are new features added in the kernel all the time. And none of those new features are documented in this book. Okay. But the classical LaTeX that evolved out of the 1980s and all through the 1990s is what is documented in this book. Let me now show you the new canonical documentation for LaTeX, and I have to bend down here to pick it up because it's quite heavy, and you'll see why in just a moment. Ah, here it is. Now, for scale, this is twice the thickness of Mr. Thorne and Wheeler. Okay, so this is two gravitations side by side. This is the brand new LaTeX companion uh, published by Frank Mittelbach and Ulrich Fischer. This is in 2 volumes. It is available in both hardback and digital. If you order from the publisher, you get a free copy of the digital edition, I think. Don't hold me to that. I ordered mine on Amazon. But this, unfortunately, is the new canonical documentation for anything related to tech and LaTeX. It is quite expensive, but it is a once in a lifetime purchase. And it does include all of the new things like the floating point library. Are you aware that LaTeX can do floating point numerical computations now? Well, it can. And many, many other very cool things, some of which we might need today, most of which we probably won't. But this is the new canonical source. This is not something that you're going to sit down and read in one night, like the Lamport book. This is something much more encyclopedic that you refer to when you need it for a specific situation. But it does include a lot of things that have not been documented elsewhere. And one last thing, one of the problems with LaTeX is the documentation. There is a lot of documentation out there. And if you have LaTeX installed locally, believe it or not, you can access all of this documentation from the command line. Now, I'm a Mac user, and I know that a lot of Mac users don't like the command line. But if you're a Windows or a Linux user, you're certainly probably familiar with the command line. The tool we're going to use today is called Overleaf. And Overleaf is an online portal that provides you with an editing environment to create LaTeX documents. There's also a TechLive distribution running in the background on the server. But there is one weakness with LaTeX, and that is there's no way to access all the documentation for the various packages that you might want to use. But never fear, I have a solution for that. And so, unless anybody has any questions, fire up a web browser and let's go to overleaf.com and just log in. And I'm going to attempt to share my screen here. This worked in rehearsal, so let me see if this works. There we go.
It's okay, Joe.
Okay, and let's see, is that full screen or not?
Mine is full screen.
Okay. So when you go to Overleaf, and by the way, the accounts at Overleaf are free. And in the interest of transparency, I am an Overleaf ambassador, so I do get a free account with all the bells and whistles, but it's bells and whistles that I have never even used. So I basically just do the kinds of things that I'm doing today. So full disclaimer there. So when you get into Overleaf, and by the way, if anybody has any trouble logging in, let me know. I believe you can log in with various social media credentials, your Google credentials should not be a problem. But this is what you should see when you log into Overleaf. Now, yours is going to look a little different from mine. I have various projects that I use here, and some of these are several years old. Some of these I created just earlier today. And what I would like for you to do is we're going to create a new project, and I'm going to create one too. So over here on the left, let's click on New Project, and we're going to create a blank project. And let's call it Optics Workshop. And click Create. And when you create a new project, you are thrown into that project, and notice that Overleaf creates a tech file for you that by default will be named main.tech. And that file name extension is very important. So we're not going to change that. However, in a few minutes, I'm going to show you how to change the name of this main file over here because we will have need to do that. And notice that there may be some information filled in for you over here. And by default, I believe this little sample document will be compiled and you'll have a nice little PDF file over here. Now, the first thing we need to do is to set up our workflow. So from this view inside your project, I would like you to come up here and click on Menu. And this is exactly what it says. It's a menu of workflow options. Now, we're going to set some things here for the work that we're going to do today. And if you continue to use the software that I created, you will need to set up all of your projects in this way. The good news is this is a one-time setup, okay? So under compiler, I would like you to set that to Lua LaTeX. The reason for this is that the Lua LaTeX compiler understands Unicode characters. And the traditional default PDF LaTeX compiler does not understand Unicode characters. It can be coerced into doing so, but it's not easy to do. So the recommendation is that the Lua LaTeX be the default document compilation engine for all new users. And I'm assuming that everyone here today is a new user. So set that to Lua LaTeX. The Lua is the name of a scripting language, which I believe is Brazilian for moon. You can actually script in LaTeX with Lua. I have not learned how to do that, but this particular compiler supports that capability should you want to learn how to do that. But we aren't going to do anything like that today. The next thing I need you to do is to set the Tech Live version to 2024. The tech ecosystem is released every year, usually around the March equinox, and it is released by the name Tech Live. If you are a Mac user, it comes under the name of Mac Tech. But if you're Windows and Linux, it comes under the name Tech Live. And so you always want to make sure that if you're on Overleaf, especially if you're a new user, that you're using the most recently released Tech Live distribution. Now, one problem with Overleaf, this is the second of two problems. I already told you about the first one, the lack of easy access to package documentation. But Tech Live is released every year in March. It is August, and I believe Overleaf only upgraded to Tech Live 2024 in July. They only do a system upgrade once a year, and this is for stability reasons. They have users all over the world at academic institutions and industries and so forth using various versions of tech. And the big problem comes when people try to do their doctor's or master's thesis or doctoral dissertations using a template provided by the universities. And that sort of locks you in to a specific version of the tech distribution and sometimes package versions. So Overleaf has this capability here for you to change the backend server, the Tech Live distribution that you're using. And we're going to set that to 2024. The other reason for this is because if we set this to 2024, you're not going to have to upload my software because it's already included in Tech Live. So if you download Tech Live 2024, you will have the software that I'm going to show you how to use today. We want to keep, at least for the purpose of this introduction here, we want to keep this main.tech file set to main.tech. You can, the editor provides spell check. I'm just going to leave that set to English. And there are all sorts of other options here that you can set. I'm going to make the font size a little bigger. Uh, and I'm going to set that to 18 point just so everybody can see what I'm doing. By all means, you set that to your personal preference. PDF viewer, you can use the built-in one from Overleaf, or you can use your browser's capability. I'm just going to leave that set to Overleaf. You can change the font. This is like very much like configuring your own editing environment. And you can even choose the theme. I'm not going to mess with that. But it's very important to have Lua LaTeX and TechLive 2024 and main.tech set. Okay. And then when you're done, you can just click out here in the editing environment, and those options will stick for this particular project. Let me just pause here and ask if anybody has any questions thus far. Was everybody able to get to this point? Because now we're actually going to start doing something.
Or sorry, Joe, is it really
Yes.
quickly?
Yes.
I guess sounds like there's no like global defaults. You would have to set these with every new project.
I think it's set by project.
Okay, cool. Thanks.
And we're going to clone a project in just a minute. And when you clone them, I think those settings are cloned as well. So if we were to clone this Optics Workshop project, those settings would be cloned into that new project that we create. Okay? All right. Now, let's actually create some content. Here's what I would like you to do. Starting with the line use package, we're going to change graphic X to Mandy, M-A-N-D-I. And that name has dual purpose. It can be read as M and I, as in matter and interactions, or it could be read as Mandy, the name of the girl I was dating when I first created this software many years ago.
Joe, sorry to interrupt.
Yes.
One of our participants, Pankaj, says they cannot create an overleaf account due to limitations of the organization account.
I see that, and I don't know what to tell you about that. I've never seen that. I've never seen that error before. Um, are you on an institutional network or something like that?
Account, and personal account, personal email, and as well as institutional. Somehow it says, you cannot create one.
Of organ. Are you at a university?
No, I am not, the university where I work, they do not offer physics.
Okay.
So I've taught AP physics and I've taught, college chemistry and
Okay.
biology. First time me into a physics workshop, but that's okay. I can just watch and be here.
Try this. Try creating a personal account, not affiliated with an organization or anything like that. Just try creating
Try
a
that.
fresh personal account and see if you can get in that way. And don't use like an institutional email address or anything like that. See if that works.
Trying that.
Did you want us to use Mandy?
Yes.
Okay.
Yes, absolutely. And we're going to get rid of these lines here that say title, author, and date. We aren't going to need those. And all of the content is between begin document and end document. So what I'm going to do now is show you some of the things that Mandy can do. So here's what we're going to do. We're going to write our first sentence. And we're going to talk about momentum here. And I'm going to type something here, and I will comment on this in just a moment. Okay. Now let me explain what I did in this line here. First of all, don't worry about white space because LaTeX doesn't care about white space. So we're just typing a very simple sentence here, and you may notice that I use some delimiters here. These delimiters put LaTeX into math mode. Now, if you look this up in the references that I showed you earlier, you will see $signs used for this. This is sort of the classical way of getting into and out of math mode, single $signs like this. You can also use backslash parenthesis, which is the way that I have been doing it for years, and I am in that habit, and I'm probably not going to be able to get out of it. So apologies in advance if that confuses anybody, but this just simply tells that anything that's inside those delimiters is going to be in math mode. Okay. And notice that I used a command called momentum. Where have we seen that before? Aha, we have seen that in introductory physics. And notice that I supplied a number, in this case 5, in curly braces. Those curly braces are going to be important. Okay. And even though it's not essential, I'm going to get rid of that blank line. It doesn't matter. You can put it in there if you want to. And then I'm going to come over here on the right, and I'm going to click recompile. And this is what you should see. And by the way, over here where it says recompile, you can have it compile as you type. I find that very annoying, and I find that that can cause the server to slow down and your session can lock up. So I have mine set to auto compile off. That means it only compiles when I click the button. Now, hopefully, you got a clean build and you got no errors. Let me show you what happens if you get an error. I'm going to misspell the word momentum, and I'm really going to mess it up. And I'm going to click recompile. Over here on the right, if you get an error, you should see a red box next to the big green recompile button. The 1 means I have one error, and if you click on that, one of the things I love about Overleaf is that it parses the error message from LaTeX and puts it, hopefully, into plain, understandable English. In this case, it tells me that I have misspelled the name of a command. It doesn't recognize the momium command. I have apparently misspelled something. And the key is to look at this line right here. And the very last thing at the end of that topmost line is the thing that the compiler thinks you have misspelled. That's where your attention should go. Okay, forget all this other stuff right here. This other stuff here doesn't matter. It's that last item at the end of the topmost line. Oh, look, that should be momentum. So I'm going to come over here, and I'm going to hopefully spell momentum correctly. momentum. And now when I recompile, that error should go away and I get a clean build.
How
So
did you make the text larger in size, or change the font size? Oh, over there.
over
Okay,
here. Yep.
thanks.
This is a just a sort of a standard PDF viewer. You
Thanks.
can zoom in, you can zoom out. That's how I'm doing that. Okay, and this is what you should see. Now, the thing I want to point out here that I think is innovative is notice that it put the units there. I simply told it momentum, and I gave it a number 5, and it typeset the units for me. So this solves one problem that we frequently see with introductory physics students, and that is students leaving off units. So what I did was I made this package very intelligent. For every physical quantity that appears in the Matter and Interactions textbook, I defined a command whose name is the name of that quantity. And I built in the units, the SI units, for every one of those physical quantities. Okay, so let's change momentum to energy. And we have to change that 2 places here. So what do you predict we're going to see on our PDF file this time, when we typeset this? Joules, exactly.
Yeah, joules.
Yeah. So let's recompile and let's see if it knows the units of energy. Oh, look at that. It does. Now, I did not distinguish with separate commands for things like kinetic energy, potential energy, so forth, because it's all energy, okay? And it all has the same unit. Name a physical quantity that you use in introductory physics. We've done momentum, energy. Name another one. Let's see if it's included. Acceleration, says Raj. Okay, so let's go back here and let's do acceleration. And see, the key here is that the command is the name of the quantity. And I'm going to recompile this, and let's see if we get the correct units for acceleration. Oh, look at that, we do. And Pankaj says force. It should print newtons. Let's just double check that to convince you that I really did make this intelligent. And I did. Okay. Oh, but wait a minute. Force is a vector, correct? So what if we want a vector? So here's what we can do. We can simply add the word vector to force. Now notice that this is all I'm going to do, and I'm going to recompile this, and this is going to generate an error. And I actually made this error message very intelligent here. It said, you provided one component to a command that expects a vector. Either you don't need a vector or you didn't supply all the components. Wow. Mandy is really smart. It's saying you're using a vector command here, but you only gave it one component. So let's give it some other components, and I'm just going to make these up. There's nothing special about them, and I'm going to work in 3 dimensions here. 5, -3, 2, and notice that we get a beautifully typeset vector. The angle brackets are used in Matter and Interactions, so that's how I've formatted them here. Over in the chat, can you change it to other units? For example, use dynes instead of newtons. No, this is SI only. Amanda asked, what about density? I believe what you want to use there is mass density. And let's just feed it a number. And let me compile this and see what happens. Oh, that generates an error. Okay, so it says mass density, it doesn't recognize. So let's just try density. And it doesn't recognize that either. So here's what I'm going to do. I'm going to open up another tab, and I'm going to go to techdoc.org. This is a website that has every piece of documentation for TeX and LaTeX that exists. And what I'm going to do here is I'm going to type in Mandy, and it's going to find it. And oh, look, there's the documentation for Mandy. And I'm just going to click on that thing right there and pull it up. And here in the documentation, I have predefined physical quantities. And this is a list of every quantity that Mandy knows about. And these are all in the index as well. So I'm scanning through here. I was thinking that I did include linear mass density, linear charge density. Oh, I think it's going to be under V. I think it's going to be volume mass density. Let's see. There it is right there, volume mass density. So if we go back to our document and do this as volume mass density, this should give us kilogram per cubic meter. Okay. And charge density is included. You can do linear charge density, you can do area charge density, you can do volume charge density. Okay, so, and there is an API for creating new quantities that we're not going to need today, but that is documented in the documentation there. And by the way, this techdoc.org website is how you solve the problem of Overleaf not showing you the documentation. So you have your document that you're working on in one window, and then in another tab, you can have the Mandy documentation open. And this is the latest version. Raj asks about the \vec command. That is for typesetting symbols. So let me come back over here. I'm going to go back to momentum just because I like momentum. And I'm going to make a momentum vector. By the way, you can put the word vector in the front as well. So you can say vector momentum. And again, I'm just going to make up some components here. And I'm going to change force to momentum. And now we have to do something if we want to typeset this as an expression. I'm going to add a use package Mandy student. Okay. The Mandy bundle is actually 3 separate packages. The first one, Mandy, all it does is the unit stuff. If we want to start doing other things, we're going to need to load the Mandy student package. And the Mandy student package loads Mandy by default. So you can just change use package Mandy to use package Mandy student. And now inside here, let's see, what is the symbol for momentum? I believe it's a P, correct? Oh, by the way, if you have the latest Physics Today, there's an article in there about the urgency of having a name for the unit of momentum. I have not read that yet, but I understand it's creating a bit of a stir. So you might want to check that out. So I'm going to hit recompile here. And you might be able to predict what this is going to do. There's our expression now. And notice that it created a nice vector symbol. But now, if you've used LaTeX before, you may know that the vec command usually produces an arrow. But I changed that in Mandy Student. And the reason I changed that is because I wanted students to get used to seeing boldface. The arrow notation was invented for use at the chalkboard. And since this is not a chalkboard, I don't think the arrow notation is appropriate. However, it's still there. I left it in. If you do vec star, in other words, if you just use the starred form of the vec command, which I defined in the Mandy student package, this will get back the traditional arrow notation. I made it just a little bit harder to get to because I did have a bit of an agenda here. I wanted students to use boldface for vectors. Okay. So I'm going to take the star away because I like seeing the boldface notation there for vector quantities. And again, that's a personal choice. And I'm not going to say any more about that than just to say that it's a personal choice. Let me just pause here and see if there are any questions. Is everybody able to replicate what they're seeing on my screen here? I see Anthony with a thumbs up. Let me bring up the chat. Yes, okay. All right. I figured if things were going wrong, people would say something. So I'm treating the silence as understanding, as I usually do in the classroom. So knowing that there are probably some things going on. Let's see. David Fieldbaum. For me, the vec notation results in an arrow. Are you loading Mandy student? If you do it with just Mandy, I don't think I redefined the vector command in just Mandy. So if you load the Mandy student package, it will change to boldface by default. The packages are somewhat independent, but I made them intelligent so that if you load Mandy student, it will automatically load the Mandy package as well, so it will know about the units. But change Mandy to Mandy student, and I think that will fix your problem, David. Mandy student, yes, all one word. And the next thing I'm going to show you is the main thing in the Mandy student package. It worked. Yay, excellent. Excellent, excellent, excellent. I really did put a lot of thought into this software. You're seeing about 10 years worth of evolution in this software here. The first versions, when I showed it to the tech developers online, they literally made me cry. They said, this is absolutely terrible. You shouldn't do this. So during the pandemic, I spent a lot of time rewriting this software to bring it up to date and to make it more robust and to make use of all these cool features that have been built into LaTeX over the years that I had no idea even existed. So I really have put a great deal of effort into this software. Okay, so let me show you now how to write up a solution. Okay, so we're going to come over here to our document. And there is a construct in LaTeX called an align environment. Don't worry if you don't know what that means. It's a formatted way of presenting mathematical materials with, for example, the equal signs all lined up and everything. But I didn't want students to have to mess with that. I wanted students to think in terms of physics. So what I did, if you go back to the documentation, if you go to the Mandy student package, okay, So here you can see that in the Mandy student package, this is where I have redefined the default vector notation. We can do subscripts and superscripts. But there are two things that I want to point out for us today, and that is right here. Problems and annotated problem solutions. This is what's going to change your world in the physics classroom. So notice that I have created two environments. One is called physics problem. And then down here, we will see that there is another one called physics solution. Now, these are really just aliases for built-in LaTeX environments, but I made them semantically logical for the student. So let's first write a physics problem. So what you do in your document over here is you begin a physics problem. Every begin must have a corresponding end. And this editor is so smart that it will choose the right name for that environment for you. If you've typed begin physics problem, it knows that you're going to need an end physics problem. Now, every physics problem must have a title to it. This is not optional. This forces the student to think about what they want to call their problem. And notice that this is inside curly braces. And this is all documented. There's a full example in the documentation here. Source code and compiled versions. But you simply write your physics problem right here in situ. And when you compile this, it will format it very nicely for you. I'm going to take out this first thing that we did here and recompile, because what it did, I designed it so that every new physics problem starts on a fresh page. This eliminates that problem for you. So there we go. Notice how it makes a heading out of the title of the problem. And then it writes the actual problem below that. Now you can include any content you want here. I'm just going to make one up. Calculate the momentum of a ball with mass. Now, we need a mass. What command do you think I'm going to use to tell it the mass of this ball? Give it a wild guess. I want to specify a mass. So what command am I going to use? I'll give you a hint. It starts with an M and rhymes with glass. Mass, exactly. The name of the quantity is the name of the command. Now, I don't know what the mass of this ball is. I'm just going to make up something. I'm going to say it's 1.3. And notice that I don't have to tell it the unit, because Mandy knows the units. But let's make it a fancy, let's give it a 3D velocity. So I'm going to say vector velocity. You can also say velocity vector. You want to work in 2D or 3D? Let's work in 3D. Okay. Now I'm going to typeset this. Boom. There's the problem. I'm going to decrease that just a little bit. So notice that it handled the units for us. You'd be surprised at how many textbooks do not correctly typeset SI units. Are you aware that there's like a 200-page book on how to correctly write typeset units? For example, they must never be written in italics. They must be written with Roman upright letters. There must be a space between the number and the unit. There's very strict typesetting guidelines for SI units, but they are seldom followed. Well, they're followed here. And part of the logic is that it gets students used to seeing this. It's used to seeing the units typeset correctly. Okay. So there's our problem. Now we need to write a solution. So we're going to come down here and we're going to now begin a physics solution environment. Pankaj asks, can we prepare and save the typeset codes in a Word doc and paste them on Overleaf for quicker use? I would recommend not mixing Word and LaTeX, because when you copy from a Word document, you may pick up some invisible characters that will generate an error in your LaTeX file. And if they're invisible, you're not going to be able to see them. Debugging that sort of thing is very, very, very difficult. I would recommend not mixing Word and LaTeX. Do it in a text editor like Notepad or something. All you need is an ASCII text editor, because a LaTeX file is just an ASCII file. It's not XML or XHTML or anything like that. It's just a plain UTF encoded ASCII text file. And every begin needs an end. So we're going to need an end physics solution. Now, here's where the fun happens, because here's where we have to actually type something here. So let's start out. Let's see. Let's write the equation for momentum, and let's assume Newtonian physics is applying here. So there's no relativistic speeds or anything like that. So let's say that the momentum is equal to mass times the velocity. Okay, now this is just a formula. But now let me show you something else that I built into this. How many times have you had students write out a solution and you asked them to show their work and they didn't? I think all of our hands should probably go up there. So here's what I did. I invented a reason command, and I required students to add this to every step of their solution. So here we can just say definition of momentum. And then out at the end, we need a double slash. That tells us we're going to continue this on the next line. And you may notice that there's an ampersand in front of the equal sign. What that's going to do, as we type more lines, you'll see that that ampersand is going to tell LaTeX to line up all of those equal signs for us. This is going to be beautifully formatted. And I can't spell definition, can I? Okay. All right. So what do we want to do on the next line here? Substitute numerical values. Okay, I heard someone say, let's do that. So you can either rewrite that vector P, or you can just leave a space for it. I'm going to leave a space for it. Now watch how I do this. I'm going to open up parentheses. And by the way, the physics solution environment is already in math mode. So you don't need to do anything to tell it to go into math mode. So watch what I do here. I'm going to say mass. And what mass did we give it? 1.3. Now this will typeset that in parentheses for us. And we need to typeset this velocity vector. So we need to say vector velocity, and I gave it 1, 2, 3. Now we need a reason for this step. Every step must have a justification. So what you want to call here, substitution. And then we'll need a double backslash out at the end. Okay, now we're ready to do the computation, right? So we can do this two ways. This is the point where a student would normally pull out a calculator. And I'm sorry now that I used 1.3 because I can't, well, yeah, I guess I can do this in my head. And I can't spell vector velocity either. There we go. So at this point, the student has a choice. They can either pull out a calculator and do the calculation the old-fashioned way. I had my students write a Python script for every problem, but there is another option, and that is you can make LaTeX do the computation for you. I'm not going to do that here. I'm going to give you a template in just a few minutes that does illustrate how to do that. But now we're simply going to say vector momentum, and can we do this in our head? This is going to be 1.3, 2.6, and 3.9. Did I get that right?
Yes.
Okay, and this is our final answer. Inside a physics solution environment, the last line does not take the double backslash. In fact, that may generate an error. Okay. So I'm just going to pause a minute here to let everybody sort of get caught up. Oh, I like to do one thing down here on the last line. I like to add a therefore. And again, this is just purely a stylistic thing for me. I like to add a therefore sign. And let me typeset this. And I want you to look at that. So this is sort of a holy grail for us. We have no handwriting to decipher. Units are used correctly and consistently all the way through. Each step has a justification, and notice that each step is automatically labeled. So now in an oral examination, I can say, you might want to take a look at step number 2 in your solution because I think you have a numerical error. Maybe you used the wrong mass there. So it creates this beautifully typeset solution. We no longer have to worry about units. We don't have to worry about them not showing their work. We don't have to worry about deciphering handwriting. Everything is beautiful. Is everybody able to get to this point?
Working on it.
Okay. I'm a fast typer, and I realize that not everyone is a fast typer. Okay. I'll shut up here for a minute or so and let everybody catch up. My students loved this. They said, it looks just like it looks in the physics book. And I said, aha, that's because your physics book was created with LaTeX. And I happen to know that the 4th edition of Matter and Interactions was done in LaTeX. And I had a little bit of a role in getting Bruce and Ruth to use LaTeX for that. So it was beautiful. David asked, is it vector momentum or momentum vector? Either one. I made this very, very intelligent, David. So any quantity that is a vector, you can simply prepend the word vector, or you can append the word vector to the name of the quantity, and it should work. I tried to make this as intelligent as possible so students wouldn't have to struggle with memorizing a bunch of things. I wanted to make the names as flexible as possible. I mean, obviously momentum, that can't be flexible. The quantity is momentum, but whether the vector goes in front or after the name of the quantity, I made it smart enough so that either one will work. It's completely transparent to the student. I really did put a lot of thought into the semantics of the commands. Like I said, this physics solution, it's nothing more than an align environment, but that's not very semantic. I wanted students to think, okay, I need to write a physics solution. And by the way, I should also point out that the physics solution is for mathematical content. If you give them, for example, an essay question that doesn't require any step-by-step mathematical stuff, they don't have to use the physics solution environment to give their answer. They can just give their answer after the physics problem environment. I hope that makes sense. And I also should point out that the documentation includes all of the source code. So this is all open source. This is free. You can look at the source code. You can even steal it with attribution if you want to. That's all in the license agreement. But this is all thoroughly documented I spent more time on the documentation than I did on the actual code. What questions do you have at this point? So each step in the solution is defined after the reason. Not really. Because this is an alias for the LaTeX align environment, each line delimited with the backslashes defines a step semantically. So for example, where this first double backslash occurs, everything in front of that is one step in the solution. Everything from the first double backslash to the second double backslash is one step, but they are numbered automatically sequentially as they appear in that environment. So reason is optional, yes. I tried making it required, but I couldn't find a way to do that. I wanted the compiler to crash if they didn't put a reason there, and I'm still looking for a way to do that. I haven't figured that out yet. But I told them it was required, and they didn't question me on that, and I never had any problem with it. And I also told them to make their reasons as short as possible, 1, 2, 3, 4, 5 words. If you put a long reason in there, it will, well, let me just show you what it will do. It will correctly format. It's actually a mini page environment, so it will correctly format it like that. And notice that it correctly numbers the steps. So it's a pretty intelligent reason command. So they can put complete sentences there if they want to, but I told them that fragments, are good. But of course, Lord knows they can make their solutions as complete as they want. I'm not going to stop them from doing that. But yes, technically it is optional as far as LaTeX is concerned.
Hey, Joe, is there any reason for indentation, or it's just I see that the vector is indented a little bit.
Oh, okay. So that is purely my coding style. LaTeX doesn't care about white space. So I like to see my equal signs aligned. So if I were doing this for me, I would do this just because that's what my brain wants to see. It helps me keep track of where I am, but that's entirely optional. You can just as well do this. And no one is going to complain. And it's all the same to LaTeX. The white space doesn't matter.
If you
I'm
have
old and
things,
I'm sorry?
if you have, okay.
Go ahead.
If you have lines that are highlighted in red, what does that mean?
You mean like physics solution?
No, I have a white background, and then my whole begin physics problem, my physics problem is red, and there's a red dot before the line number.
I'm going to stop sharing my screen and I'm going to ask you to share your screen.
Okay.
Okay. See if you can throw your screen up there
Okay, let me see.
and I'll show you how to debug that.
Do you see it?
Okay. So let me see. Begin physics. Oh, I see the problem. I see the problem.
Okay.
Do you see the problem in line 12? I'm being a bit of a smart aleck there. Something in that line is misspelled. Do you see the problem?
Problem? Oh, I forgot the R.
Ah,
Wow.
yes.
And that much.
Yep.
Oh,
Okay, Anthony, thank you.
thank you. I'll unshare now.
I bet you'll get a clean build this time.
Okay.
So hit recompile. And let's see what happens. And this is how I teach the students to debug as well. Okay, so there's a problem there.
Probably
Now, begin physics solution, end physics solution. Something is misspelled there as well. PHYSICS. Oh, you need double backslashes at line 22.
So here.
At the end of line 22.
At
the end of
at
line
the end,
22.
end
Yep.
of line 22.
Yep. And look at line 21.
We're using R.
Aha. Now, the word substitution is misspelled, but that's not going to throw an error because that's not the name of a command. So LaTeX is not going to flag that as an error. So hit recompile there.
Okay.
And you got a clean build.
Okay, but my
Notice
spelling is
that
off.
it did not, but the spelling of and it didn't catch the substitution because that's not the name of a command. There's no backslash in front of that. So it didn't detect that as an error. So otherwise you got a clean build there.
Okay, thank you.
Okay. Yep. Now, let me show you what we're going to do next. I'm going to put my screen back up there. I am going to put a document into the chat. And this is a document that you can get from the GitHub page where Mandy lives, but I'm going to give it to you. Let me get back to Zoom. Let me just momentarily stop sharing and go over here to the chat. Okay. And I'm going to drop a file into the chat area. And this is a tech file. And I'm going to, we're going to upload this to Overleaf. Okay. So now let's go back into Overleaf. And so I've shown you how to create a rudimentary solution here. So we're going to come back up here and we're going to click on this little home icon, and this will take you back out to your list of projects. Now, here's what I would like you to do next. We're going to create a new project. Okay, and we're going to create a blank project. And here's what we're going to name this one. Whoops, wrong keyboard. I've got 3 keyboards here in front of me, and I just started typing away on the wrong one. We're going to call this one Solution Template. Okay. And this is what Overleaf should throw you into. Now, I need you to do something for me. That file that I put in the chat for you, I need you to download that to your computer.
Okay.
And stick it on your desktop or in your downloads folder or somewhere, because we're going to do something with that file. So I'm going to assume that everybody has downloaded that. Now, we're going to now upload that file to this solution template project. Now, the way you're going to do this is you're going to click on this little icon, and this is a one-time thing, by the way. So this is the only time we'll have to do this. We're going to come over here and we're going to click on upload, and you can just drag and drop that file onto this palette, and Overleaf will upload it for you, or you can browse and find it, and Overleaf will upload it for you. But your project should now have both of these files.
Yeah.
Okay. Give me a thumbs up or something on your video there when you have that document template that I gave you uploaded. Or say got it or something like that. Just let me know that that you got it. Your screen should look like mine, basically, at this point. Okay. Now here's what we're going to do next. We're going to delete the file named main.tech because we're not going to use that one ever again. So the way you delete it is you come out here and you click on that little 3-dot. There's probably some technical term for that kind of interface element there. And we're just going to select delete. Okay. And now we're going to go back into the menu. Remember, we need to set this up to use Lua LaTeX. And this time, we're going to set the main document to be that template that I gave you. And again, make sure you set the Tech Live version to 2024. Always use the latest one that's available is the rule of thumb there. And so now, when you compile this template, this is a hugely documented template. And basically, there's going to be tons of stuff in this file that you don't need to worry about. I included a lot of things that I wanted my students to learn to do that we are not going to have time to do today. But this is a richly documented sample solution template. And this is actually what my students had. This is the exact file that my students had. And so I included a problem a little more complicated than the one we just did. I included an example of how to do a plot. I did not include this with my students because at the time I did not know how to do plots in LaTeX. I did include this part here about including source code because in my course, students had to learn to use, it was called GlowScript. It's now called WebVPython. So if they wrote a program to do a problem, they had to include the source code. There's an interface for doing that in the Mandy student package. But the cool thing here is that if you click anywhere in the gray area, or if you click on this URL right here, or if you use your phone to read that QR code, you will be taken directly to the source code for that program online. And this made grading very, very, very efficient. I could look at their code and I could see if the program would run. I could do everything except edit their code. This is a read-only type of thing here. But they could seamlessly include their GlowScript programs. And I also included an example of how to do references. I did not require my students to do that, by the way. So the source code for all of this is over here. And there are places where you are told not to edit anything, like don't change any of this stuff up here, any of this use package stuff, because you can break your document. But there are places here, like right here, line 84, your work, edit to suit. So this is what we just did. This is a physics problem environment. I used a problem with parts. There's a parts environment that you can use. So you can have a part A, a part B, part C, etc. Here's our physics solution. It's just like we did. I included some labels for cross-reference. You folks can ignore those. Don't worry about that. So this is sort of the master template, and this sort of documents everything that can be done in writing up a physics solution. So this template is going to be your guide for writing up your sample physics problem. And we need to do one more thing before I turn you loose with this. So one more thing, and we'll take a quick little break here, and I'll let you work on your own thing here. Go back out to your project list. And every time a student needs to write a solution, they need to clone this template project, okay? So watch how I do this. We're never, ever, ever going to touch the template in that template project. That is our pristine starting point. So I'm going to highlight that template project, and I'm going to come over here, and we want to make a copy. Now, watch how I do this, because this is going to seem a little weird. You might notice that that file I gave you has a very strange name, beginning with a lot of N's. So what I had the students do is use a standardized way of naming their files. So I'm going to show you. So I would call this Hefner because that's my last name. Chapter 5, Problem 2. Okay, do you see how I did that? So what I had students do was use their last name, a C to indicate a 2-digit chapter number, and a P to indicate a 2-digit problem number. And that is what the new project is called.
Where did you get the copy project from?
Where did I get the what?
Copy project?
Oh, okay. So you select the little square next to the
Oh,
solution
okay.
template, and then over here,
And then-
under more, make a
Okay.
copy.
Okay.
I
Thank
think it
you.
used to be called cloned, but I think they changed it to make a copy. But so that first that actual solution template is never touched. You only make a duplicate of it when you want to write up an actual solution. That way the student doesn't overwrite it. Okay. And this naming scheme was, again, just something that I came up with that I found to be very manageable. At the end of a semester, the students would have a whole named library of problems and solutions, and they knew exactly what chapter and they knew exactly what problem that solution pertained to. And I did tell them that one solution per project. I wanted them to organize it that way. They didn't necessarily like that at first. I know a couple students wanted to keep a running project with everything in it. That just became a logistical nightmare, which they soon discovered. And they appreciated at the end of the course how having this nice, beautifully organized library, what a huge benefit that was, especially if they were moving on to a next course. Let's see, Tony, I think I missed a step after deleting the main document. Okay, so what you want to do is come back here after you delete that main document, is go under the settings menu, and you want to just make sure that you set the compiler to Lua LaTeX, the Tech Live version to the latest available, which is 2024. And then here's the most important part. You're going to change the main document to that template file that I gave you. Each project must have a dedicated main document. That is the document that is compiled every time you enter that project. And there has to be one, or Overleaf gets very, very confused. And so you just want to make sure that that template file is the new main document. Joseph asks, with the GlowScript block, is the code automatically pulled from the GlowScript file? No, they need to copy and paste it. And one giant copy and paste is all it should take. Because the GlowScript block, that's an environment. So all they have to do is say begin GlowScript block, end GlowScript block, and then literally just paste their program in between those two lines and then compile. They do have to supply the URL as well. They do have to supply the URL. And so we had to learn to use URL shorteners. However, I found out that URL shorteners are not good because they create accessibility problems. So I had to reformat things a little bit to accommodate long URLs there. So you can click on the URL to go to the program. You can read the QR code, or you can simply click anywhere inside the gray code window, and that will open up another tab with the program on the GlowScript server. I made it very, very intelligent, and it is very, very cool. And notice that now with this little sample program here, it might not be obvious, but the code is pretty printed. It's formatted for them and everything. That's all built in. They don't have to do any of that. Mandy takes care of that for them. I'm pretty proud of this, actually. I put a lot of work into making this. I was going to say cool, making it utilitarian for incorporating the code. Because in Matter and Interactions, the code is a very important part of the curriculum. And they have to supply a caption as well. But other than that, the software does all this formatting, numbers the lines, pretty prints it, color codes it, everything. So here's what I would like you to do for the remainder of our time together. I asked you to bring a textbook with you, to choose a physics problem so that you could write up the solution. It doesn't have to be a complex program. It doesn't have to have any code associated with it. But what I would like for you to do is sort of use this template as a guide for writing up your own solution. There are examples of things here. For example, if you look at, where is it? Well, there's use of Mandy commands in here. There's use of mathematical symbols. Don't worry about creating a graph. Creating graphs in LaTeX is very, very difficult unless you know the secret. Once you know the secret, it's almost trivial. The problem is the secret is documented in 1,000+ pages of the PGF plots in the TIC-Z manual. Maybe we can do another workshop on that later on, but that is not something that I'm going to talk about today. That's another whole separate topic, generating graphs, but I included an example there. What I wanted to show you was in steps 6 and 7 of the solution on page 2. In steps 6 and 7, those numbers are actually calculated by LaTeX when the document is compiled. Now, this was not this easy to do when my students were doing this, but it is now completely possible to do a LaTeX document that does numerical calculations and never have to leave LaTeX to use a calculator or a computer. It can do all of that built in. And I included a couple examples here on how to do that. If you look inside that solution, there it is. Look down around line 117, line 118, 119. The code in those lines shows you how those 5.997s were evaluated. Because if you look very carefully at the code, you never actually see 5.997 anywhere in the code. That's calculated at compile time when the document is compiled. And that's all just built into LaTeX now. And I actually showed 2 ways of doing it there. So here's what I would like you to do. I would like you to pick a problem from the textbook or a textbook, or if you don't have a textbook handy, create your own little physics problem and use this template, create a new project for your example solution, and spend some time trying to write this up. And I will be here in case you have questions about things. I'm going to temporarily stop sharing my screen.